Alright, and we are moving on to Chapter 2, solving this equation for your Bell problem. Don't forget to distribute your numbers, your 3 and negative, to every term inside your parentheses. Solve it, come back, and we'll have the answer for you. The answer you should get for your Bell problem is C equals 5. Again, you need to get C on one side, numbers on the other. If it helps you, draw a line down the equal to sign. This is the first section of 2.1, Relations and Functions, and at the end of this section you should be able to graph and identify relations and functions. You should be writing these vocab terms on your Chapter 1 vocab sheet already passed out to you in class. Number 1 is a relation, a set of pair of input and output values. 2 is domain, set of inputs, the x coordinates of our ordered pair. And 3 is range, the set of outputs or the y coordinates of our ordered pair. Now again, an ordered pair is in parentheses. Since we read left to right, your first term needs to be in alphabetical order. So our first term is our x, our second term is our y, and again they're separated by a comma. So the first number in your ordered pair is the domain value, and the second number, or the y, is your range value. Some more definitions. Number 4, a function is a relation in which each element of the domain corresponds with exactly one element of the range. Number 5, independent variable, x represents the input of the function. And 6, dependent variable, is f of x or y represents the output of the function. So if we had f of x equals x plus 3, our independent variable would be x, and our dependent variable would be f of x, because we are going to plug in any number for x to figure out what our value would be for y, or f of x. Next, a relation can be represented in the following ways. Again, an ordered pair. We can have our x and our y values, so again, they're in parentheses. Our numbers are separated by a comma. The first number is our x, or our domain values, and the second number is the y, or the range values. If you take these ordered pairs, they're going to be the same for the other 3 ways to represent a relation. The table, again, your first column is your x, so second column is your y, and if you notice the terms, your ordered pair, we go straight across. So we have negative 2, 2, and that goes in our table in the first line. Then go over to your graph. X is your horizontal axis, y is your vertical axis. So to remember, x, horizontal, horizon, the flat. Vertical is like a ladder. And look at your first ordered pair. We're going to graph the ordered pair negative 2, 2. When we are graphing, we go left and right first. So we take our negative 2, we go to the left 2 since it's negative. And since our y is positive, we go up 2, and we plot that point. The last way is our mapping diagram. Notice how we have input and output on the top of our 2 ovals here. Also notice that the numbers are in least to greatest order starting at the top. So we go from negative 2, 0, and 3. If you look back over at our ordered pairs, notice how we have 2 negative 2's, but we only have 1 over here. Since that is the case, we never write repeats inside our mapping diagram. You only write it once. We can represent it with 2 separate arrows. So our first example. When skydivers jump out of an airplane, they experience free fall. The photos show various heights of a skydiver at different times during the free fall. How can you represent this relation in 4 different ways? Now, first we have to determine what is our x values and what is our y values. I'm going to make our x values the time, or the seconds, and our y values would be the feet, or the height at which our skydivers are at. Now remember the 4 ways to represent them. You have your mapping diagram, your ordered pair, your graph, and your table. Go ahead and draw all of those out. Again, when you're doing your table and your mapping diagram, don't forget to put them in least to greatest order. The same thing goes for this example. The monthly average water temperature of the Gulf of Mexico and Key West, Florida, varies during the year. In January, the average water temperature is 69. In February, 70. In March, 75. And in April, 78. How can you represent this relation in 4 different ways? So don't forget the 4 different ways. Draw them out. Don't forget the repeats. And come to class prepared to talk about them tomorrow. Next, we are considering this relation given the ordered pairs. We have -2, -3, -1, 1, 1, 3, 2, -2, and 3, 1. We have to identify the range, or the domain and the range. So first, starting with the domain, we're going to put a capital D out front to represent domain. Then follow that with a colon and the little squiggly thing I can never draw. Next, when you're identifying the domain, remember that is the x values of all of our ordered pairs, and rewrite them in least to greatest order with no repeats. So we first look to find the number that is the least, which should be -2. When I do these, I cross them out as soon as I use them. So we use -2. I don't see any other -2, so we move on to our next number, which would be -1. Cross that out. And then we have 1, 2, and 3. They're nice to us. They didn't give us any repeats, and they put them in order. They're so nice. Now, since we are done, you end it with your little squiggly, and move on to the range. Since we represent a domain with a capital D, we represent range with a capital R, followed by the colon again, and the little squiggly thing. Hopefully someone else is better at drawing that than I am. And we do the same thing with the range. You still go least to greatest, no repeats. So look, we have -3, 1, 3, -2, and 1. So our least is -3. Cross that out. I don't see other -3s, and I found another negative number, which is -2. So that'll be our next number. Cross that one out. Then we're left with 1, 3, and 1. So 1 will be our next number. Again, notice how we have a 1 here and a 1 here. We do not write the repeat, we just write it once. And our last number is 3. Alright, and C, represent the relation using a graph and a mapping diagram. You go ahead, make the graph, and I will help you with the mapping diagram. Remember, when you're doing the graph, the numbers on the horizontal are your x, and on the vertical is your y, and you always move left and right first, then up and down. Make sure to plot all 5 points. I will help you with the mapping diagram. So at the top, we put inputs. Just a little rough with a little oval underneath it, and then we have output. Now, this example made it really easy for us because we identified our domain and our range. So what we do, we take our domain numbers, since they're already in least to greatest order, and there's no repeats, we just put them inside our oval here. So we have -2, -1, 1, 2, and 3. Then for our output, we put our range values. So we have -3, -2, 1, and 3. Then, since this is a mapping diagram, we have to draw our arrows. So we go back up to our first ordered pair, which is -2, -3. So you start your input, draw it to your output, and you're done with that one. Then we have -1, 1. Then we have 1, 3. Then we have 2, -2. And last but not least, we have 3, 1. And you are done. Go ahead and identify the domain and range of this relation. Don't forget no repeats and do them in least to greatest order. Come back and I will say them out loud. For your domain, remember you have a capital D followed by a colon and a little squiggly. And you should have -3, 0, 2, 9, and 23 for your domain. And for your range, you should have -99, -18, 0, 7, and 14. Here is the homework, and we will continue 2.1 tomorrow.